We often look up at our night sky. We see the moon, a familiar, comforting presence. We see the stars, scattered like diamonds on black velvet. This is our view of the cosmos, the one we have known for all of human history. It has shaped our myths, our science, and our sense of place in the universe. But what if we were standing somewhere else? What if we were on a different world, orbiting a different star? I want you to imagine that for a moment. Feel the strange ground beneath your feet, breathe the alien air, and then look up. What would you see? The universe is vast. It contains billions of galaxies, each with billions of stars. Around many of those stars we are now discovering, there are planets, worlds of rock and ice and gas. Some are scorched by their suns, others are frozen in perpetual darkness. But some might be just right. They might have liquid water. They might have atmospheres. And on those worlds there might be life. Life that has evolved under a completely different sky. A sky that would be both alien and beautiful to us. A sky that has shaped their own story, their own science, their own dreams. Let's take a journey. A cosmic journey beyond our familiar blue planet. We will visit worlds that we are only just beginning to discover. We will stand on their surfaces and gaze at their skies. We will see sights that no human has ever seen. Multiple suns casting long, overlapping shadows across the landscape. Giant planets hanging in the sky like colossal, decorated moons. Nebulae painting the heavens with vibrant colors. This is not science fiction. These are real possibilities based on what we are learning about the cosmos every single day. This journey is about more than just seeing strange new sights. It is about perspective. It's about understanding that our view from Earth is just one view among countless others. By imagining what an alien might see when they look up, we can better appreciate our own place in the universe. We are part of a grand cosmic tapestry, woven from stars, planets, and perhaps life. So let us begin. Let's leave our world behind and step out into the great, wondrous expanse of the cosmos to see what other skies have to show us. Our first stop is a planet orbiting a red dwarf star. These are the most common types of stars in our galaxy. They are much smaller and cooler than our sun. A planet needs to be very close to a red dwarf to be warm enough for liquid water. Imagine standing on such a world. The star in the sky would look very different. It would be a huge, deep red orb, hanging in the sky like a giant smoldering ember. It wouldn't shine with the brilliant yellow-white light of our sun. Instead, it would cast a perpetual, dusky crimson glow over everything. The sky itself would not be blue. The color of our sky is caused by our atmosphere scattering the sun's blue light. On this world, orbiting a red dwarf, the light is mostly red, so the sky would likely be a pale orange or a soft salmon pink. The days would be long and dim, like a permanent sunset on Earth. Because the planet is so close to its star, it would likely be tidally locked. This means one side always faces the star, and the other side always faces away. One hemisphere in permanent daylight, the other in eternal night. Life here would have to adapt to this constant, dim, red light. Plants, or their alien equivalent, might be black or deep purple. They would evolve to absorb as much of the red light as possible for photosynthesis. Animals might have very large eyes to see in the low light. They would navigate a world of long shadows and muted colors. The concept of a day-night cycle as we know it wouldn't exist for them. Their rhythms would be tied to something else entirely, perhaps the slow, subtle shifts in the red dwarf's light. The night sky, on the side facing away from the star, would be spectacular. With no sun to wash it out, the stars would be incredibly bright. The Milky Way, our home galaxy, would stretch across the sky in breathtaking detail. It would be a river of light, far more vivid than we can ever see from our light-polluted cities. For any intelligent beings living here, the galaxy would not be a faint, distant object. It would be a dominant, awe-inspiring feature of their reality, inviting them to explore its mysteries from a very early age. Now let's travel to a different kind of world. Not a planet orbiting a star directly, but a moon orbiting a giant gas planet. Imagine a world like Jupiter, but in another solar system. This gas giant is a colossal ball of swirling clouds and storms, and we are standing on one of its many moons, a moon with a rocky surface, a thin atmosphere, and perhaps oceans of liquid water hidden beneath a shell of ice. When we look up, the sky is dominated by the immense, beautiful presence of the gas giant. This planet would fill our view. It would be a magnificent sight, far larger and more detailed than our moon appears to us. We would see its colorful cloud bands, its swirling storms, and its famous Great Red Spot, or an alien equivalent. The gas giant would go through phases, just like our moon. Sometimes it would be a thin, glowing crescent. At other times, it would be a full, brilliant disk, lighting up the landscape with its reflected starlight. Its presence would be a constant, powerful reminder of the gravitational dance of the cosmos. The gas giant would also have a powerful magnetic field. This field would trap particles from its star's solar wind. These particles would then be channeled towards the poles of the gas giant, creating spectacular auroras. But these auroras wouldn't just be on the planet, they would also appear in the sky of our moon. Imagine vast, shimmering curtains of green, pink, and blue light, dancing not just at the poles but across the entire sky. These celestial light shows would be a regular, nightly occurrence, a breathtaking display of cosmic physics. Life on this moon would evolve under this dynamic sky. The cycles of the gas giant's phases would be their month. The auroral displays would be a part of their natural world, just as clouds and rain are to us. Any civilization that arose here would be deeply connected to its parent planet. Their observatories would not just look at distant stars, they would be intensely focused on the giant world that hangs above them, studying its storms, its rings, and its other moons, which would appear as bright points of light moving across the sky. Our next destination is perhaps one of the most alien environments imaginable. A planet in a binary star system, a world with two suns. Let's imagine we are on a planet that orbits both stars. From the surface, we would see two suns moving across the sky. They might be different colors. One could be a large yellow star like our sun. The other could be a smaller orange or white companion. Their dance in the sky would create complex and beautiful patterns of light. The daily cycle here would be unlike anything we know. There might be times when both suns are in the sky at once, creating a bright, intense day. The light would be brilliant, and every object would cast two distinct shadows. Then, one sun might set while the other remains in the sky, leading to a period of dimmer daylight. There might be brief periods of true night when both suns have set below the horizon. Or depending on the orbit, there might be no night at all for long periods of the year. This complex interplay of light and heat would have a profound effect on the planet's climate and on any life that evolved there. The seasons would not just be determined by the planet's tilt, but by its long, looping orbit around the two central stars. There would be periods when the planet is closer to one star and then the other, creating complex and perhaps extreme temperature swings. Life would need to be incredibly resilient to survive. Perhaps creatures would hibernate or migrate to follow the more temperate conditions across the planet's surface. Imagine a civilization growing up under two suns. Their architecture might be designed to manage the intense light and heat, with deep overhangs and reflective surfaces. Their timekeeping would be incredibly complex, based on the positions of both stars. Their mythology would be filled with stories of two sun gods, perhaps brothers or rivals, whose celestial dance dictated the fate of the world below. Their astronomers would have a fascinating puzzle to solve, working out the intricate gravitational mechanics of their three-body system. The sky above a planet is not just a pretty backdrop. It is, a fundamental force of nature that shapes everything below it. The type of star, the length of the day, the presence of other celestial bodies. All these factors would drive the course of evolution in unique ways. On a world with a dim red dwarf star, life might develop senses beyond sight. Perhaps it would use echolocation or sense faint electrical fields to navigate a world where vision is limited. Their biology would be a direct response to the low-energy light they receive. On a moon orbiting a gas giant, life might have to contend with intense radiation. The gas giant's powerful magnetic field, while creating beautiful auroras, would also channel deadly radiation. Life might have to evolve underground, or in deep oceans protected by a thick sheet of ice. Any creature that ventured onto the surface would need a natural shield against this radiation. Their very cells might have powerful repair mechanisms far beyond what we possess to cope with the constant bombardment of high-energy particles from the sky. Consider a planet with a very short year, orbiting its star in just a few of our days. The seasons would whip by in a blur. Life would have to adapt to these rapid changes. Plants might grow, flower, and seed in a matter of hours. Animals might have incredibly short lifespans, living their entire lives in what would be a single week for us. Their whole perception of time would be different. For them, a human lifetime would seem like an eternity. Their world would be one of frantic activity, lived at a pace we can barely imagine. And what of the mind? How would these different skies shape intelligence and consciousness? A civilization that never experiences true darkness might have a different concept of sleep and dreams. A culture living under the constant watchful eye of a giant planet might develop a deep sense of cosmic community, seeing themselves as part of a larger family of worlds. The sky is the first page of the book of science. The patterns and cycles seen by an alien civilization would be the first great puzzle they would seek to understand. Let's return to that tidally locked world, orbiting a red dwarf. Specifically, let's visit the Terminator Zone. This is the ring of land that lies in perpetual twilight between the scorched day side and the frozen night side. Here, the red sun hangs forever on the horizon. It never rises. It never sets. The light is a constant gentle dusk. This narrow band of habitability would be a unique cradle for civilization. It would be a world of eternal sunset, a place of profound stillness and quiet beauty. The cities built here would be unlike any on Earth. They might be long, linear settlements stretching for thousands of kilometers along the Terminator line to maximize their access to this habitable zone. The architecture would be designed to capture the faint horizontal light of the low-hanging sun. Perhaps buildings would have large side-facing windows or giant sail-like structures to gather light and energy. The constant twilight would influence their art, their music, and their philosophy, creating a culture defined by subtlety and shadow. Life for the inhabitants would be structured not by the rising and setting of the sun, but by other, more subtle rhythms. Perhaps the slight wobble of the planet in its orbit would cause the sun to dip and rise a tiny amount over a long period, creating a slow, grand day. Or perhaps their society would be governed by clocks, with work and rest cycles completely detached from any natural celestial event. They would live in a world of stability, a world without the dramatic daily change that has defined so much of life on Earth. This stability, however, could be a double-edged sword. While it provides a predictable environment, it might also foster a less dynamic worldview. Would a civilization that has never seen the stars on the day side or the sun on the night side be as curious about what lies beyond their world? Or would their unique position, with a window to the stars on one side and a source of energy on the other, make them uniquely suited for cosmic exploration? They would live on the literal edge of light and darkness, a powerful metaphor for the boundary between the known and the unknown. Every civilization that looks up with curiosity will eventually become astronomers. Just as we built Stonehenge and the pyramids to track the sun and stars, an alien civilization would build its own great observatories. On a world with two suns, their observatories might be vast, complex structures. They would need sophisticated computers to calculate the movements of their three-body system. Their telescopes would be designed to look at two stars at once, studying their flares, their sunspots, and their intricate dance. On a moon orbiting a gas giant, the focus would be different. Their greatest observatory might not be a telescope pointed at deep space, but a network of sensors aimed at the giant planet above. They would study its atmosphere, its magnetic field, and its dozens of other moons. Their space program might begin not with rockets aimed at other stars, but with probes sent to explore their own planetary system. Their interplanetary travel would be our interlunar travel. The gas giant and its family of moons would be their entire universe for a very long time. Imagine a civilization that evolved on a planet shrouded in thick clouds, where the stars are never visible. They might live for thousands of years without ever knowing that there is a universe beyond their atmosphere. Their science would be focused inwards, on geology, biology, and chemistry. Then one day, they develop the technology to leave their atmosphere. They send a probe above the clouds. For the first time, they see the stars. Imagine the revolution in their thinking, the sudden, shocking realization that their world is not alone, but is a tiny speck in a vast, glittering cosmos. These observatories would be more than just scientific instruments. They would be monuments to their civilization's curiosity and ambition. They would be their equivalent of the Arecibo dish or the Hubble Space Telescope. They would be places of wonder, where generations of alien scientists would gaze out into the void, asking the same questions we do. What is out there? Are we alone? They would map the sky, catalog the stars, and search for the telltale signs of planets orbiting those stars, driven by the same innate desire to understand their place in the universe. As their technology grows, these alien civilizations might begin to look for others. They would scan the skies, searching for planets that look promising. They would look for worlds in the habitable zone of their stars. They would analyze the light passing through the atmospheres of those planets, looking for the chemical signatures of life. They would search for oxygen, for methane, for water vapor. They would be looking for a world like their own, or perhaps a world like ours. From a planet orbiting TRAPPIST-1, a cool red dwarf star just 40 light-years away, an alien astronomer could look in our direction. Their star is faint, so our sun would appear as a moderately bright yellowish star in their sky. They might detect the tiny dip in our sun's light as the planets of our solar system pass in front of it. They would detect Venus, Earth, Mars, and even Jupiter. They would calculate our orbits and our sizes. They would know that there is a small, rocky world in the habitable zone of this yellow star. Using their advanced telescopes, they might be able to analyze the light reflected from Earth. They would see the blue of our oceans. They would see the green of our continents. They would see the white of our clouds and our polar ice caps. They would analyze our atmosphere and find that it is rich in oxygen, a highly reactive gas that on its own is a strong indicator of biological activity. For them, Earth would be a prime candidate for life, a pale blue dot full of promise and mystery. They might even detect signs of our technology. The radio waves from our broadcasts have been traveling out into space for over a century. For a civilization 40 light-years away, the earliest signals would just be arriving. They would be faint and jumbled, but they might be detectable. They might also see the faint artificial light from our cities on the night side of our planet. They would see a world that is not just alive, but intelligent. And they would wonder, just as we do, what kind of beings live there, on that distant blue world. Our journey through alien skies brings us back to a profound and beautiful idea. The idea that we are not the only ones looking up. When we gaze at the night sky, we are participating in a universal act, an act that may be shared by countless other beings on countless other worlds. Across the vast distances of space and time, there may be other eyes, other minds, all contemplating the same cosmic spectacle, each from their own unique perspective, under their own unique sky. This thought can be humbling. It reminds us that our sun is just one star among billions. Our Earth is just one world among trillions. Our sky is just one of many possible skies. But it is also deeply inspiring. It connects us to the rest of the universe in a fundamental way. The laws of physics that create the auroras on a gas giant's moon are the same laws that govern our world. The atoms that make up a distant star are the same atoms that make up our bodies. We are all made of stardust. The search for life beyond Earth is one of the greatest scientific adventures of our time. It is driven by this deep desire to know if we are alone, to find another watcher in the darkness. We build ever larger telescopes. We send robotic probes to the other planets in our solar system. We listen for signals from the stars. We are reaching out, hoping to find a reflection of our own curiosity somewhere out there in the great, silent expanse of the cosmos. So the next time you look up at the night sky, remember the worlds we have visited. Remember the crimson glow of a red dwarf, the twin suns of a binary system, the majestic presence of a gas giant. Remember that on some distant world, under a sky you can barely imagine, there might be someone else looking back. Not at our star, perhaps, but at their own, filled with the same sense of wonder, asking the same questions. We are all children of the cosmos, connected by our shared journey through the universe.